All right, let me catch up to you guys. So data's all in there. I didn't sort anything, thank God. The fourth option. So I got these. Is that the same thing you guys got? Thank God. All right. So I got 0.738. Right there, what do you guys think about that? 0.738, what's your gut tell you? Is that a good correlation or not? Yeah, it's decent, right? It's decent. So thankfully, I'm not going to make you describe R values like you would wine. You're like, oh yeah, that's a decent. No. So I'm going to give you very obviously good or very like 0.9 versus 0.1 or something, right? So you're not going to have to be like 0.63 is a kind of good. Oh my God. Also, I'm going to give you, for example, for this one, if I remember correctly, R had to be greater than 0.456 to show evidence of correlation. Did we show evidence of correlation? R has to be bigger than 0.456. We got 0.738. Is that evidence of correlation? Yes. If I had a bigger sample size, this number would be smaller. I'd need less evidence then because I have a big-ass sample size. Okay, I like it. So is it strong? It's decent. Decent positive correlation. Positive correlation means as one thing increases, so does the other. Or as one thing decreases, so does the other. Negative correlation means they are inversely related. If one goes up, the other one goes down, and vice versa. The equation of the line of best fit was 0.66x plus 71 roughly. What'd you guys get for A? 0.66. What'd you get for B? 71 roughly. Yes?
How are we going to know like what to round? Because in the first one you rounded different.
I don't know. So in general, the little bits. Do you see how this would be 70.9668? I'm going to round up to 71. I don't care which. If you use this place here, you're going to go up to 71. I was just telling somebody else, if you round to 3 places, you're fine. You almost can't go too far out. I just don't want to look at 9 decimal places worth of stuff, right? But if you went out really far, I'm not going to take points off.
What about R?
Same thing. Same thing. Yeah, I went 2 on this one, didn't I? I went 3. Ha ha. So just go 3. I love you guys so much. Just go 3 places. That's fine. Right? Or if you go back to what I said way earlier, if you take everything to 4 places, you're covered everywhere. Right? Okay, I like it. Would you trust this to make a prediction? Yeah, good, because it's a decent correlation. So I'm going to say this. Before this, what would be my best guess for somebody's grade? It would just be the average grade. That would be my best guess. But since we did this study on this data, I can now improve on my prediction if I know how many hours they spent studying. I don't have to just use the average. I can use the hours to make a better prediction. Could I do that on the first set of data I used? No, because its correlation sucked. So I'd have to use the average for a guess. Here, I don't have to use the average grade. How much am I going to get? Oh, the average. How about me? The average. Oh, thanks, man. But if I said, how many hours did you study? Oh, I predict you're going to make this. How many hours do you study? Oh, you're going to make this. And why am I allowed to do that? Because my correlation was pretty decently strong. Okay. So here, how would I predict, let me add a little question on here. How would I predict the grade for studying, let's do 23 hours. Help me out. In this equation, what does X represent? Number of hours studied. And what does Y represent? The grade. So how do I, for 23 hours of studying, how do I predict what grade that person will make? I put a 23 in for freaking X. All right. See why algebra is important?
This is not an algebra class. This is statistics, but it uses the shit out of algebra. So if you haven't taken much algebra, that's why you're not doing so well. All right. So if you do this, y equals 0.66 times 23 plus 71.
86.8 or 86.82.
Joseph. You're too fast. No, you're good. That's right. I just wanted to say Joseph. So yeah, I like it. So I predict 86.18. I like it. And look, isn't 23 right in between 22 and 25? So 86.18 sort of in between those. It's a averaging of the data points. Does this mean that person will definitely make this? If I study for 23 hours, I will make exactly an 86.18. Yeah. No, doesn't mean that at all. There's other factors to consider. But if everything else is decent, you should make close to this. Does my study that we just did, does this mean that if I study for more hours, my grade will go higher than it would have been?
No.
Does it mean that for sure? No, it does not mean that at all. It doesn't. It does not mean that. It's the same thing about if I play more basketball, I'll get taller. It's the exact same mistake. This study cannot tell you that. All this study says is there seems to be a relationship between hours and grade. The study is dumb. It doesn't know who affects what. All it can say is there's a relation. Now, we know more than likely if you studied more, you probably would get a higher grade, but that's not what this study can say. It's beyond this study's scope. Are you guys? You'd have to do a very controlled thing about control exactly how many hours, and then you get the same test, and then you do it to more groups of people. Oh my God. We didn't do that. We just kind of like gave a test and said, how long did you study? How long did you study? Okay. Maybe. So do you notice what the real work here is putting the data in, getting the numbers out. You have to interpret what you get. That's what you got to do. I'm not making you calculate what you're going to get, but you have to interpret what you get. So, Joe, yeah.
Yeah, so when you do that linear thing on the stats, you get like for B with 70.96, is that the average of like all those?
No. Remember, what's the y-intercept? In this case, physically, what would the y-intercept mean? That person studied 0 hours. That's what I would predict for somebody who studied none. If you didn't study at all, that's my predicted grade for you. Does that make sense? The y-intercept, the b, will always mean if x value is 0, none of x, whatever x represents, that's what the outcome would be. So if you didn't feed your fish at all, this would be the length of the fish after a couple of days. Right? That's the idea. So after 0 days, what's the length of the fish? That would be what the b represents. Okay. So this here, you're going to love because it involves y minus y1 equals n times x minus x1. Does that sound familiar? Whatever, math boy.